Okay, so the YouTube video we're using for this deep dive is called How AI Took Over the World. Pretty dramatic, right?
Yeah, a little ominous.
But before we all start building underground bunkers, let's, actually look into how AI got so smart, minus the whole robot apocalypse scenario.
Right, and what's fascinating is that the video basically argues that AI's development mirrors our own learning process. It breaks it down into these 3 layers. It starts with evolutionary learning, then moves to reinforcement learning, and finally it gets to language.
3 layers, huh? So kind of like how we learned to ride a bike. First, you're totally wobbly, then you figure out how to balance, and then you're cruising down the street without even using your hands.
Yeah, that's a great analogy, actually. So just like that wobbly first stage of learning to ride a bike, AI first learned through random exploration. The video gives this really interesting example. It's about this early tic-tac-toe machine that used matchboxes and beads.
Okay, now that sounds more like a kindergarten art project than, world domination. How did that even work?
So each matchbox represented a different point in the game. And inside the matchbox, you had all these beads that symbolized possible moves. The machine would basically just pick a bead at random, so a random move. And if it won, you would add more beads of that same color to the matchbox. It's like rewarding the machine for making the right move. And over time, it actually started to learn winning strategies.
So it started off totally clueless, but it got better through basically trial and error and rewards. Pretty clever. But how did we go from matchboxes and beads to, AI that can write poetry and code?
Well, that's where that second layer comes in, reinforcement learning. So instead of just totally random exploration, AI started to learn from specific feedback. It got better with each try, but there was a limit to how far this could go without one crucial ingredient, abstraction.
Abstraction. Okay, so now we're getting a little more, abstract. What does that even mean when we're talking about AI?
Think of it like this. Abstraction is basically the ability to see the forest for the trees. It's about recognizing the important patterns and ignoring those tiny details that don't really matter. The video actually talks about this man who couldn't form abstractions. He could remember every single detail of everything, but he was just completely overwhelmed by the sheer amount of information. He couldn't see the big picture.
Wow, I can't even imagine trying to live like that. It would be like trying to read a book, but every letter was a different size and color. Just completely overwhelming. So AI needed to learn to simplify things, just like we do as humans, to make sense of the world.
Exactly. To move past just basic pattern recognition, AI needed to learn how to create those mental shortcuts, just like we do. So researchers started looking to the human brain for inspiration.
So they were basically trying to reverse engineer the human brain to build better AI. That's pretty cool. What did they find?
They realized that the brain isn't just one big blob. It's this complex network of neurons, and they fire in these layers. And that layered structure became the blueprint for something called artificial neural networks.
So they basically created artificial brains, like with tiny little computer neurons.
Well, not exactly tiny, but yeah, you've got the basic idea. One of the earliest attempts was this thing called the perceptron. This was back in 1958. It actually used electrical components to mimic neurons and their connections. And it could learn to recognize simple shapes, but it was still pretty limited.
Okay, so we've got these artificial neurons forming these networks. But when did things really start to take off? When did AI go from recognizing shapes to, basically taking over the world?
Well, that's when we get to the rise of deep learning. Remember those layered networks? Well, researchers figured out how to build networks with many more layers, hence deep learning. And that opened the door to much more complex pattern recognition. And a really pivotal moment for deep learning came with this thing called the ImageNet competition. This was back in 2012. It was a huge deal because it was the first time that an AI system actually beat humans at image recognition.
Oh, yeah, ImageNet. I remember reading about that. Wasn't it like 1 million images or something?
Over 14 million, actually. And the AI system had to correctly identify what was in every single image, everything from dog breeds to different types of flowers. It was a serious turning point for the field.
So this win basically showed that deep learning was like the real deal.
But didn't it also mark a shift, from just recognizing patterns to actually predicting them? You're exactly right. Think about a game like chess or Go. Instead of just recognizing the current board position, AI started predicting the best move based on tons of data. And that was all thanks to deep learning. This led to some pretty incredible achievements, like AlphaGo. You know, the AI that beat a Go champion?
Yeah, that Go match was legendary. But wasn't there another piece of the puzzle that helped AI take an even bigger leap forward? Something about language.
Absolutely. Language became that third layer of learning, and it's a total game changer. I mean, think about it. Language allows us to learn from other people's experiences. It lets us build upon existing knowledge, and it even allows us to imagine things that have never existed before.
Yeah, I get why it's important. But how do you even begin to teach AI something as complex as language? It's not like you can just hand a computer a dictionary and say, go forth and understand.
Right. Well, that's where it gets really fascinating. Researchers started to look at language as a pattern itself, like a sequence of predictions. And Claude Shannon, he's a pioneer in information theory. He was really key in this whole shift. He showed that the words we use are influenced by the words that came before them.
So it's like each word is a clue.
Yeah.
And it helps you predict the next word in a sentence, kind of like a code to crack.
Exactly. And in the 1980s, researchers actually started training these early neural networks to predict the next word in a sequence. And what they found was that these networks could group similar words together. They were forming this basic understanding of grammar and meaning.
So just by playing this word prediction game, these networks started to grasp the underlying structure of language. That's incredible. But how do they go from predicting words to creating whole sentences and paragraphs?
Well, a major breakthrough happened in 2015. This researcher, named Andrzej Karpathy, he showed that these language models could not only predict patterns, but they could also generate them. He trained a network on this massive data set of text, and it could write convincingly in all these different styles, from Shakespeare to even like math equations.
Wait, so they went from predicting the next word to like composing like Shakespeare. That's a pretty impressive glow up.
It really was a pivotal moment. And then came OpenAI with GPT-1. It was this much larger language model, trained on thousands of books. GPT-1 could continue text prompts coherently. But what's really cool is that it could also answer questions that weren't directly stated in the text that it was trained on.
So it could actually understand the meaning of the text, not just parrot it back. That's like a whole new level of comprehension.
Precisely. And with each new iteration, from GPT-2 to GPT-3, these models became more and more powerful. They were more sophisticated. They were trained on even larger data sets. So they were absorbing this vast amount of human knowledge.
And then, of course, came ChatGPT. I feel like that's when AI really kind of entered the mainstream. Suddenly everyone was using it to write poems and emails, even code. Did you play around with it much?
Of course. It's an incredibly versatile tool, and it really showed the practical applications of these really advanced language models. But what I find particularly intriguing is this discovery that AI, like humans, actually performs better when it can think out loud.
Think out loud. So is AI talking to itself now? Is that how it becomes self-aware and decides to, take over the world?
Not quite. It's more about letting the AI system kind of work through a problem step by step and explaining its reasoning as it goes. And this actually helps it clarify its own thought process, and it leads to more accurate results.
So it's like when you're trying to explain something to someone else, and in the process of explaining it, you actually understand it better yourself.
Exactly. This discovery suggests that AI can actually leverage both quick intuition and that slower, more deliberate reasoning, just like we do. It's not just blindly following algorithms anymore.
So it's becoming more and more human-like in its thinking. But is it limited to just language? Can it understand other types of information, like music or videos?
That's a great question, and the answer is a resounding yes. The concept of language has actually been expanded to encompass other domains.
Hold on, so you're saying music is a language, and videos are a language. My brain's trying to keep up here.
Think of it this way. Anything that can be broken down into a sequence of elements can be treated as a language. A song is a sequence of notes. A video is a sequence of frames. Even a robot's movements can be seen as a sequence of actions.
That AI can learn the grammar of a dance routine or the syntax of a symphony. That's mind-blowing.
Exactly. This is what we call multimodal understanding. AI can now process and generate patterns across text, images, audio, video, even physical movements. It's all connected.
Okay, so we've got AI that understands language, music, video, even robot motions. Where does it all lead? What's the big picture here?
That's the million-dollar question. And it's one that even the top AI researchers are grappling with. The video that we're looking at, it really highlights both the incredible potential and the uncertainties that come with this really rapid development.
Right. There's a lot of talk about the ethical implications of AI these days. Are we on the verge of a robot uprising? Should we be stocking up on canned goods?
Well, let's unpack those concerns and explore what the future might hold in the final part of our deep dive.
Okay, so we've covered a lot of ground here. From AI mimicking evolution to mastering language, and even moving beyond words into this whole multimodal world.
Yeah, it's been quite a journey. Really makes you think about what's next.
Right, like where does all this lead? What happens when AI gets as smart as us? Or even smarter? Should we be worried? Excited? A bit of both.
Well, the video we're looking at, it features some pretty interesting thoughts from some leading AI researchers. And you can really see both sides of the coin. Some researchers are super optimistic. They see AI as this really powerful tool that can help us solve some of these huge problems we're facing, like, curing diseases, fighting climate change, even creating incredible art.
Right, I can see that's like
Our-
AI could be this amazing partner,
Yeah.
helping us create a better future. But then there's like the flip side.
Exactly. There are some really valid concerns, too, about things like job displacement, algorithmic bias, and even the potential for AI to be used in harmful ways. It's like any powerful tool, really. It can be used for good or for bad.
So it's not just about making AI smarter. It's about making sure it's aligned with our values and goals, making sure it's used ethically.
Absolutely. We need to make sure these AI systems are transparent, accountable, and designed with human well-being in mind. It's really about steering this powerful technology in a direction that benefits everyone.
The video also talked about this idea of AI agency. What does that even mean? Are we talking about robots demanding voting rights?
Not quite. It's more about the level of control and decision-making power that we give to AI systems. Right now, we're mostly in control. AI is a tool that we use. But as AI becomes more and more sophisticated, we need to think carefully about how much autonomy we grant it.
So it's like finding the right balance between AI's capabilities and human oversight. It's like teaching a kid to drive. You let them take the wheel, but you're still there to guide them and hit the brakes if needed.
Yeah, that's a perfect analogy. We need to figure out how to empower AI while making sure that human values and judgment stay at the heart of its decision-making.
Okay, so what does all this mean for us regular folks? Should we be prepping for a future where robots rule the world?
I don't think it's about robots ruling the world. It's more about AI becoming more and more integrated into our everyday lives. I mean, we're already seeing it with things like AI assistants, personalized recommendations, even self-driving cars.
So it's less about this sudden takeover and more about this gradual shift, this blending of human and artificial intelligence that's happening all around us.
Exactly. And the key is to approach this shift with curiosity and critical thinking. We need to embrace the potential of AI to make our lives better while being aware of the challenges and working to minimize the risks.
Well said. So for everyone listening out there, what role do you see AI playing in your life? Are you excited about the possibilities? Or a bit apprehensive? What do you think the future holds?
Yeah, and maybe even more importantly, what can WE do to shape that future, to make sure that AI is used to benefit all of humanity? It's a conversation we all need to be part of.
That's a fantastic thought to leave us with as we wrap up this deep dive into AI. Thanks for joining us and keep those brains buzzing.